In this presentation, we're going to look at binary search trees and, in particular, important terminology related to binary search trees. So, here's a list of the things we're going to look at. We're going to look at a node, or a vertex as it's also called, a key or a record number, the root, levels and height, parent and child, descendant and ancestor, subtrees, and end vertices. Here's a representation of a binary search tree. The vertices are known in programming as nodes. So I'm going to call this a node. Vertex is an equivalent terminology that comes from graph theory, but in computer programming we would call these nodes. Both phrases are good. Also, you notice that each of these are numbered. So this is key. This number here is 1. It sort of says this is node 1, node 3, node 7, and so on. So these are the record numbers, or the keys, of each node. You notice that they go in the numbers go in ascending order from left to right rather than top to bottom. That's an important point, and I'm going to come back to that in another presentation. The next thing we're going to look at is the root, levels, and height. The root is the top vertex, the top node, and it is used to represent the start of a process. So this is the root, and it's at level 0. We call that a level 0. These two vertices, or nodes, are at level 1. And these are level 2. And these are at level 3. These nodes are at level 3. The height is the maximum number of levels. So the height of this binary search tree is 3, because we have it goes down to level 3. So height equals 3, as in the maximum number of levels. Now we're going to look at parents and children, and descendants and ancestors. Well, we can see here, I'll take for example 3, that 3 is a parent of 1 and 5. So 3 is a parent of 1 and 5. And conversely, that means that 1 and 5 are children of 3. Okay? Now, we could sort of expand this notion a bit further. So we could sort of say that 7, the node, is an ancestor of 13, where you have 7 and 11 and 13, but we would say equally that 13 is a descendant of 7. In fact, everything is a descendant of 7 because it's the root. Next, we're going to look at subtrees and also end vertices. Let's look at node 7. Node 7 has 2 subtrees. The first subtree is the left subtree, which is all of these parts here, which is the child of 7, which in this case is 3, and all descendants of 3. So this is we call this the left subtree. Equally, we would have the right subtree as well, which we would have from starting with node 11, all all descendants of node 11, and there we have them there. And we would have the right subtree. Okay. Lastly, we're going to look at the end vertices. End vertices are the nodes that have no children. So all of these nodes down here are end vertices. They have no children. Okay. We would also call them external nodes.